For years, humanoid robots have amazed people with videos of running, jumping, balancing, and moving almost like humans. But impressive demonstrations don't answer the question that really matters. Can these robots work safely and reliably beside people every day in real-world environments? As we move through 2026, Tesla Bot Gen 3 is expected to officially enter the market, competing with established names like Boston Dynamics, Hyundai, and Chinese companies such as Unitree and Agibot. One major factor is price. Tesla's Gen 3 is expected to cost around $20,000, while competitors like Unitree already offer robots such as the R1 and H1 for roughly $6,000 to $14,000. The discussion is no longer about which robot looks the most advanced. Instead, it's about which one is truly prepared for real-world deployment. Before comparing specifications, it's important to separate three very different ideas: technical demonstrations, controlled testing, and real-world deployment. Mixing these together creates unrealistic expectations. To evaluate Tesla Bot Gen 3 fairly, we need a practical framework that focuses on long-term performance instead of impressive videos. As more deployments begin and real-world data becomes available, this approach will provide a much clearer picture. Humanoid robots themselves are nothing new. For years, we've watched machines run, jump, maintain balance, and perform remarkable movements. However, a successful demonstration doesn't guarantee a successful product. A robot might perform perfectly during a carefully planned presentation, but struggle in unpredictable environments. The biggest challenge has never been making robots move like humans. The real challenge is getting them to repeat useful tasks safely and consistently for long periods while working beside people. That's exactly where Tesla believes Optimus Gen 3 has made meaningful progress. Of course, Tesla isn't alone. Boston Dynamics Atlas has long been considered the leader in humanoid mobility. Hyundai is taking a more industrial approach, focusing on logistics and factory automation. Instead of comparing promises, we should compare each company's design philosophy and deployment strategy. Today, Tesla Bot Gen 3 is discussed alongside Atlas and Hyundai's robotics projects. The conversation has shifted away from flashy movements. The important question now is simple: which robot can safely perform useful work day after day? Many people assume the robot with the most impressive movements is closest to commercialization, but that's often not true. Safety and reliability matter far more than spectacular acrobatics. Atlas delivers incredible demonstrations, but these usually happen in carefully controlled environments. Real workplaces are different. Floors aren't always smooth, people move unpredictably, and unexpected situations happen constantly. Tesla appears to be taking the opposite approach. Rather than chasing maximum speed or agility, Optimus focuses on slower, more controlled movement powered by advanced vision systems and AI software. This suggests Tesla is prioritizing safe human interaction instead of dramatic demonstrations. Hyundai follows a similar strategy by limiting robots to structured industrial environments where risks are easier to control. In robotics, true safety isn't measured by how much a machine can do, but by how well it understands what it shouldn't do. A robot that respects its limits is usually more dependable than one constantly pushing them. Energy efficiency is another critical factor. A useful humanoid robot doesn't need to be the strongest, it needs to operate economically. If frequent charging, maintenance, or human supervision interrupts its work, it isn't yet practical for large-scale deployment. Tesla benefits from years of experience with batteries, electric motors, and energy management gained through its electric vehicle business. Atlas, despite its remarkable mobility, has traditionally required higher energy use and maintenance. Hyundai focuses heavily on uptime and cost per working hour, metrics that may not look exciting during demonstrations, but become extremely important in commercial operations. The real question becomes straightforward. Would you rather own a robot capable of amazing tricks for 20 minutes, or one that quietly performs useful work throughout an entire shift? Then comes another major challenge: scaling production. Building a prototype is one thing. Manufacturing thousands of reliable robots is something entirely different. Boston Dynamics has world-class engineering talent, but large-scale commercialization remains limited. Hyundai continues integrating robots carefully into its industrial operations. Tesla, meanwhile, aims to leverage its manufacturing expertise, software ecosystem, and global supply chain to produce robots at much larger volumes. However, another issue has recently gained attention, not the robot's hardware, but the ownership of its intelligence. Reports throughout early 2026 suggest that xAI, Elon Musk's separate AI company, is playing a major role in developing the intelligence behind Optimus instead of Tesla handling all of the software internally. From a technical standpoint, this arrangement makes sense. From a business and legal perspective, however, it raises important questions. Tesla is a publicly traded company, while xAI remains privately owned. Some shareholders have questioned whether valuable technology, engineering resources, and long-term AI development are gradually shifting toward xAI. The concern isn't whether xAI can build advanced artificial intelligence. The bigger question is whether Tesla ultimately controls the software that powers its humanoid robots. If the robot's perception, decision-making, and learning systems primarily belong to another company, Tesla could eventually become mostly a hardware manufacturer, while the most valuable part of the platform exists elsewhere. In robotics, long-term success depends on combining hardware, software, and continuous learning into one integrated system. This doesn't mean Optimus Gen 3 isn't a serious competitor, but it does introduce uncertainty for those evaluating Tesla as both a robotics and AI company. Whether this partnership becomes an advantage or a weakness will depend on future licensing agreements, ownership, and long-term control. With that framework established, we can now examine where Tesla Bot Gen 3 is most likely to succeed first. New technologies rarely begin with the most difficult jobs. They usually start with repetitive, predictable tasks where risks are relatively low. That's why factories and warehouses appear to be the most practical first deployment locations. These environments are structured, processes are standardized, and daily operations are highly predictable. A humanoid robot doesn't need exceptional speed or strength to create value. It simply needs to move components, transport lightweight items, organize materials, and assist with repetitive production tasks. Tesla's biggest strength may not be its mechanical design alone, but its ability to integrate robotics into a much larger software ecosystem. Cameras, sensors, and AI models trained on enormous datasets allow the robot to recognize objects, understand surroundings, and improve over time. Compared with Boston Dynamics Atlas, which focuses heavily on mobility, Optimus appears designed to become part of an everyday workflow. Hyundai is targeting many of the same industrial applications, although with a more conservative strategy centered on logistics and warehouse automation. Tesla, however, is pursuing flexibility. Instead of programming a robot for only one task, the goal is to build a platform capable of learning multiple jobs within the same workplace. After factories, logistics centers become the next logical step. These facilities already combine people with automated systems under well-established safety rules. Optimus doesn't need to replace workers. It only needs to reduce repetitive physical labor by transporting items, assisting with packaging, and handling lightweight materials. In these situations, reliability matters far more than advanced athletic ability. A robot that quietly works 8 hours with very few mistakes provides much greater value than one capable of spectacular movements that require frequent maintenance. Tesla's strengths in battery efficiency and software become increasingly important here, while Atlas continues facing challenges related to operating costs and system complexity. Retail and commercial environments could become another opportunity, although much more cautiously. Tasks such as cleaning, restocking shelves, or assisting employees during busy hours involve greater interaction with customers, making social awareness much more important. Current humanoid robots are still developing these abilities, so these deployments will likely begin as carefully supervised pilot programs rather than large-scale rollouts. Optimus would support employees instead of replacing them and perform only clearly defined responsibilities. Healthcare and elderly care deserve even greater caution. While humanoid robots may eventually provide meaningful assistance, today's systems are better suited for transporting supplies, delivering reminders, and supporting medical staff with simple logistical work instead of direct patient care. This highlights an important principle. Robots should first be deployed where mistakes carry limited consequences. In that role, Optimus has significant potential as a helpful assistant rather than a substitute for human workers. There are also environments where humanoid robots remain far from ready. Complex construction sites, unpredictable outdoor work, and situations requiring advanced social judgment continue to exceed the capabilities of today's systems. Boston Dynamics Atlas may remain better suited for specialized research requiring exceptional mobility, but even those applications are still years away from widespread commercial deployment. Progress in robotics rarely happens overnight. It advances through carefully controlled, narrowly focused applications. If Optimus succeeds, its first real impact probably won't happen on stage during product demonstrations. It will happen quietly inside factories, warehouses, and logistics centers, where reliable daily performance matters far more than impressive videos. Beyond hardware, software, and deployment, another challenge will determine whether humanoid robots can truly operate at scale: accountability. When an autonomous robot causes harm or disrupts operations, who is legally responsible? The answer becomes more complicated when the company building the AI is different from the company manufacturing the robot. Recent reports suggest Optimus relies heavily on XAI for its cognitive software. While this could accelerate development, it also raises questions about certification, liability, and long-term responsibility. Traditional industrial robots are much simpler in this respect. Take KUKA robotic arms used in automotive factories. They work inside controlled areas with carefully programmed behaviors. When a KUKA robot accidentally struck a worker in a German factory, investigators traced the incident to an improperly configured safety system rather than the robot itself. Responsibility was clearly assigned because the machine's behavior was fully defined in advance. Humanoid robots introduce a different challenge. A machine like Atlas can recover from slips, navigate uneven terrain, and react to changing environments. If a similar robot were operating alongside workers in a warehouse, an accident could result from sensor errors, software updates, environmental changes, or multiple factors happening together. Current regulations were never designed for machines that continuously learn and adapt. That's why modern AI regulations increasingly emphasize ongoing monitoring instead of one-time certification. A humanoid robot cannot simply be approved once and considered permanently safe. Software ownership makes the issue even more complicated. If XAI controls the intelligence while Tesla manufactures the hardware, who approves software updates? Who becomes responsible if a robot misreads a person's movement or mishandles equipment? Unlike traditional industrial machines, these systems make probabilistic decisions, making responsibility far more difficult to define. Companies already recognize this challenge. During warehouse trials of Boston Dynamics' stretch robot, operators carefully monitored every movement and maintained rollback procedures whenever software issues appeared. Even controlled pilot programs required strict supervision because liability remained a major concern. Ultimately, if you were responsible for deploying hundreds of humanoid robots tomorrow, what would matter most? Battery efficiency, advanced AI, workplace safety, or clearly defined legal responsibility? The future of humanoid robots won't be determined by spectacular demonstrations alone. Success will depend on whether these machines can perform useful work safely, consistently, economically, and within a regulatory framework that businesses can trust. Tesla believes Optimus Gen 3 can move the industry closer to that future. Its strengths lie in battery technology, AI integration, manufacturing scale, and experience building reliable electric systems. Competitors like Boston Dynamics continue to lead in mobility, while Hyundai remains focused on carefully controlled industrial automation. Each company is solving a different part of the robotics challenge. The winner may not be the robot that jumps the highest or runs the fastest, but the one businesses can deploy every day with confidence. The real test begins when these machines leave carefully staged demonstrations and enter factories, warehouses, and workplaces where performance is measured over months instead of minutes. That's where the future of humanoid robotics will truly be decided. Would you trust a humanoid robot to work alongside you? Which matters most to you, intelligence, efficiency, safety, or accountability? Let us know your thoughts in the comments below. Thanks for watching. If you enjoyed this video, be sure to leave a like, subscribe to the channel, and turn on notifications so you never miss our latest Tesla and AI updates. We truly appreciate your support, and we'll see you in the next video.